this is an excellent activity to explain how to interpret information presented in box plots. So we're going to use some data on roller coasters from a roller coaster database. I didn't even know this existed, but it might be interesting to look at some point in time. And on the next slide, we're going to show box plots that display the distributions of top speeds for roller coasters in the United States. And it separates them, classifies them by whether the roller coaster is wooden or whether it's steel. So let's take a look at the box. So here's the box plot. Here is the box plot for the steel roller coasters. Here is the box plot for the wooden roller coasters. And just to remember that a box plot is a graphical representation of a 5-number summary. So we have the min, the Q1, the median, the Q3, and then the max. And the 5-number summary is divided up into quartiles. We have 4 quartiles, one between the minimum and Q1, another 25% between the Q1 and the median, another 25% between the median and the Q3, and another 25% between the Q3 and the max. So 25% of my data is in like this whisker, 25% of my data is in the left box, 25% of my data is in the right box, and 25% of my data is in the right, well, whisker and any outlier. Okay, so that's what the box plot does. Is a graphical representation of the 5-number summary. So the first question says, what proportion, and we could change this to say what percentage if we want to, just to make it a little bit more friendly, of the steel roller coasters have a top speed of 60 miles per hour or greater. So notice our x-axis is speed. That's the variable that we're measuring here. The other variable that we've separated is whether the roller coaster is wooden or steel. Okay, but the variable that we're measuring with the box plot is their speed. So what proportion have a top speed of 60 miles per hour or greater? So I'm looking at my x-axis here, and here's 60 miles per hour, and this is all greater than 60 miles per hour. So if I go up here to the steel roller coasters, I can see that this is greater than 60 miles an hour. This is greater than 60 miles an hour. That's 25% plus 25%. So the answer is 50%. Or if I was to put it as a proportion, which is a decimal, 0.50. And I didn't even have to add the 25% plus 25% because I can see that the 60 miles per hour and lands right on the median marker of the box plot. And we know by definition that the median is the spot that divides half the data. So half the data is on that side and half the data is on that side. Okay, then the next question says, let me just get rid of some of this markings right here. There we go. Percentage. And we had there 50% or 0.50 as a proportion. What proportion of the wooden roller coasters now we're looking at, have a top speed of 60 miles per hour or greater? Okay, well, I can kind of take the same 60 miles per hour right here. And again, this is greater than 60 miles per hour, and it's just very conveniently lands right on the Q3 of the wooden roller coaster box plot, which means that 25% of the wooden roller coasters have a top speed of 60 miles per hour or greater. Which type of coaster, steel or wooden, has a higher proportion of coasters with a top speed greater than 50 miles per hour? Or are they the same? Or is it impossible to tell? Well, let's go back up to our box plots here. Let's kind of erase a little bit of this stuff so we don't have to look at it all at the same time. There we go. Okay, so I'm looking at 50 miles per hour or greater. Well, here's 50 miles per hour, right there. And this is greater than 50 miles per hour. And I see that is right on the Q1 of the wooden, and it's right on the Q1 of the steel. So for both steel and wooden, 75% of the coasters, or 0.75 as a proportion, 75% have a top speed of 50 miles an hour or greater. The second quartile, the third quartile, and the fourth quartile. Second, third, and fourth. Okay, let's press go to do some more. Same box plot, hasn't changed. Which type of coaster, steel or wooden, has a higher proportion of coasters with a top speed greater than 45 miles per hour? Or are they the same? Or is it impossible to tell? So let's go here, 45 miles per hour. This is an important question. So here's 45 miles per hour. And I want to know what proportion of the coasters have greater than 45 miles per hour. Well, you know, there is no way to tell. Because and this is a limitation of box plots. All the box plot is telling me is that, for example, this is the lowest 25% of steel. This is the lowest 25% of wooden. So I know that, like in the last question, from here greater is 75% for both of them. But for example, on the steel roller coasters, I mean, for all I know, all the slow steel roller coasters, they might be all over here. And all the slower 25% wooden roller coasters, well, there could be one over here, but all the rest of them over here. I don't know how they are distributed within those 25%. So there is really no way to tell how many or what proportion is at any point in each quartile. It's only possible to tell what the quartiles are. I don't know where the individual coasters land in the quartile. So it is impossible to determine from the box plots this question. Then the next question is, which type of coaster, steel or wooden, has more variability in its speeds? Or is the variability the same? Or is it impossible to tell? Well, here is really important to remember, how do we measure variability? Variability is measured in two ways: IQR and standard deviation. That is how we measure variability. IQR is used always when a distribution is skewed. Standard deviation is used always when a distribution is unimodal and symmetric. And when something is unimodal and symmetric, I can also use IQR. SYM. But I cannot use standard deviation if it's skewed. So IQR I can use with either of these two distributions. Standard deviation I can only use if it's unimodal and symmetric. But kind of putting that aside for right now, I'm really just concerned with the box plot, which is using the 5-number summary. And the thing about the box plot is that the lower end is Q1, the upper end is Q3, and we know that IQR is equal to Q3 minus Q1. The box portion of the box plot is a graphical representation of the IQR. So, which one has more variability? Well, I just have to look and see which box is bigger. And it seems very clear to me that the steel box is bigger, so the steel box has more variability. Now, one common mistake in looking at this problem is to say that the steel has more variability because it goes all the way from here to here. But that just represents the range. And we do not like to measure variability with the range because the range is susceptible to outliers. As you can see, way over here is an outlier. On the wooden one, I got an outlier over here and an outlier over here. The range covers that whole distance right there. What we like to use for variability when we're doing box plots is the IQR. And that is represented by, that's the middle 50% of the data, and that is represented by the box. So if I'm looking for variability, I really want to look at the IQR. So just to give another quick example there, if I had another type of roller coaster, let's say I had paper roller coasters. I know that's unrealistic, but let's just dream with me for a minute. And let's say I had a paper roller coasters, and their box plot looked like this. Well, certainly you can see that the range of the paper roller coasters is much greater than the range of the steel or the range of the wooden. But the IQR of the paper roller coasters is just the box. So, because for all I know, there was like one outlier over here and one outlier over here. Remember, I can't tell how many are in each quartile, so that's why I use IQR to measure the variability, because I'm looking at essentially the range of the middle 50%, the range from Q1 to Q3. That is the interquartile range. That's where that comes from. Okay, last question here, which we've kind of dealt with already a little bit. Which type of coaster is more prevalent? In other words, which one are there more of? Are there more wooden ones or are there more steel ones? And again, I'm looking at this, and the answer is, in common parlance, IDK. I don't know. And you don't know either. Because all the box plot is telling us is the quartiles. We know there's 25% here, 25% here, 25% here, and 25% here. So, for example, if I had, let's say there were 100 steel roller coasters, I know that there are 25 that fall between, like 27 and 50 miles per hour. I know that there's 25 that fall between 50 and 60. I know that there's 25 that fall between 60 and 70, and there's 25 that fall between 70 and 120. If there were, let's say that there were 1,000 wooden roller coasters, well, all I would know is if there's 250 that fall between, like, I don't know, 22 to 50. There's 250 that fall between 50 and 52-ish. There's 250 that fall between 52 and 60, and there's 250 that fall between 60 and 80. So even though the steel looks a lot bigger, there could very easily be much fewer steel roller coasters than wooden roller coasters, because all the box plot is giving us is the percentages. It's not giving us the actual numbers. So that's a really good problem to help you understand how to interpret box plots, I would give it some thought.